Imagine for a moment that you're an astronaut, hurtling through the vast expanse of space towards Mars. The red planet looms in the distance, a beacon of exploration and discovery. But as you journey, something strange begins to happen. Time, as you know it, starts behaving differently. It's not the ticking of your onboard clock or the rhythm of your heartbeat. It's something more profound, something that challenges our very understanding of the universe. You see, our universe has a fascinating quirk. It likes to bend and twist not just space, but time itself. This phenomenon, known as time dilation, is a consequence of Einstein's theory of relativity. It dictates that time moves slower in stronger gravitational fields and at high speeds. Now imagine living on Mars for 80 years. Due to time dilation, you'd die about 12 seconds earlier than if you lived on Earth. That's right, 12 seconds. It might not seem like much, but in the grand scheme of things, it's a testament to the incredible power of gravity and speed. As we journey through space, time itself becomes a flexible concept. Welcome to the world of time dilation. In our everyday lives, time seems constant, unchanging, but in the world of physics, time is a slippery creature. Time dilation, a concept that might feel like it's straight out of a science fiction novel, but is in fact a very real phenomenon. And the reason behind it all? Speed and gravity. But let's break it down. Imagine you're on a high-speed train racing at nearly the speed of light. Meanwhile, your friend is back home watching the seconds tick by on a clock. To your friend, time moves just as it always does. But for you on the train, time seems to slow down. This is the essence of time dilation. Now let's add gravity to the mix. Picture yourself at the bottom of a deep well. Again, your friend is topside under the normal pull of Earth's gravity. The closer you are to the source of gravity, the slower time passes. So while you're at the bottom of the well, time would actually be moving slower than it is for your friend above ground. In both these scenarios, time is experienced differently due to the effects of speed and gravity. This is time dilation. It's not about time travel or jumping into the future. Rather, it's about how time can stretch and contract depending on where you are and how fast you're moving. It's like a cosmic dance choreographed by the universe itself. Just as a dancer's movements can be fast or slow, so too can the passage of time. It can race ahead or it can crawl, all depending on the dancer's speed and the force of gravity. So, in the universe's grand dance, time does not keep a steady beat. It slows down and speeds up, influenced by gravity and speed. Now let's take this concept and apply it to our astronauts traveling to Mars. Picture this. You're an astronaut hurtling through the vast expanse of space, bound for the red planet. But as you travel, something peculiar is happening. Time is acting differently for you than it is for the folks back home on Earth. Welcome to the world of time dilation. When we talk about time dilation in space travel, there are two main factors at play. First, there's the speed at which you're traveling. As you approach the speed of light, time starts to slow down for you relative to an observer at rest. This is known as special relativity, a concept introduced by none other than Albert Einstein. This means that if you were to take a quick trip to Mars at near light speed and then return, you'd find that more time has passed on Earth than for you on your journey. But that's not the only factor at work. There's also gravity to consider. The stronger the gravitational field, the slower time passes. This is a phenomenon known as gravitational time dilation, another fascinating outcome of Einstein's theory of general relativity. As you're in a spacecraft far from Earth's gravitational pull, time would run faster for you than for people on Earth. But once you land on Mars, with its weaker gravity compared to Earth, time would again run slower for you. So how would this affect our astronauts' perception of time? Well, the effects would be minuscule for a relatively short journey like a trip to Mars. But if an astronaut were to stay on Mars for, say, 80 years, they would notice a difference. They would age about 12 seconds less than their counterparts on Earth. 12 seconds may not seem like much, but it's a tangible proof of the mind-bending reality of time dilation. Our brave astronauts, in their journey to Mars, would experience time in a slightly different way than we do here on Earth. What if our astronauts decided to stay on Mars for a while? How would time dilation affect their lives? Well, let's dive into that. Time dilation, a fascinating product of Einstein's theory of relativity, isn't just a fun thought experiment. It's a real, measurable phenomenon that our spacefaring explorers would experience firsthand were they to make Mars their home. So, how would living on the red planet change our astronauts' perception of time? Well, due to the lower gravity on Mars compared to Earth, time would actually run slightly faster for them. This effect, however, is so minuscule that it would be nearly impossible to notice in the course of a human lifetime. But what about the practical implications of this phenomenon? Could it affect the way we conduct space missions or even our day-to-day lives on Mars? In the grand scheme of things, the time dilation effect on Mars is negligible. It wouldn't significantly affect the astronauts' aging process, nor would it cause any major issues with communication between Mars and Earth. Yet, it's the subtlety that makes this phenomenon so interesting. The idea that time itself can be influenced by gravity and speed is a mind-boggling concept. It challenges our perception of reality and forces us to rethink the very nature of the universe we inhabit. However, if you were to spend your entire life, let's say 80 years on Mars, the time dilation effect would become more noticeable. You would find yourself approximately 12 seconds ahead of your Earth-bound counterparts. While this seems like a trivial amount, it's a fascinating testament to the reality of time dilation. So, if you lived 80 years on Mars, you would die around 12 seconds earlier than if you had stayed on Earth. A minuscule difference, but a testament to the strange and wonderful ways of our universe. Time dilation might seem like a curious quirk of the universe, but it has profound implications for our understanding of reality. Consider this. If we were to send astronauts on a prolonged mission to Mars, the effects of time dilation would start to become noticeable. Imagine living on the red planet for 80 years, only to find out that you've aged roughly 12 seconds less than you would have on Earth. It's a small difference, but it's a difference nonetheless. It's a testament to the fact that time, as we understand it, is not universal. This is a radical departure from our everyday experience. We're used to thinking of time as an unchanging constant, ticking away at the same rate no matter where we are or how fast we're moving. But that's not the case. Time can stretch and shrink, warp and bend. It's more like a flexible rubber band than a rigid ruler, and this has far-reaching implications for our future in space. As we push further into the cosmos, the effects of time dilation will become more and more pronounced. Astronauts on long-duration missions could return to find that they've traveled slightly into the future, relative to people back on Earth. This is not science fiction, it's a fundamental aspect of our universe. But time dilation doesn't just affect astronauts, it's relevant to all of us. It challenges our perception of reality, forcing us to rethink our assumptions about the nature of time and space. It shows us that the universe is stranger and more complex than we ever could have imagined. This realization can be unsettling, but it's also exhilarating.